To simplify a radical, we need to look at its factors that make up the radicand and see if there's any perfect indexed roots in there. Whoa, that's a heck of a lot of words there, Willie. All right, let's kind of break it down. Let's look at an example. Say, for example, I have the square root of 300. Are there factors of 300 that are perfect squares? I can think of one. And I'm going to rewrite it. There's an example. I can think of it as 100. 100 is a perfect square. It's also a factor of 300. It may not be the highest one, but I think it is. So I can rewrite root 300 as root 100 times 3. And then using this model up here, this product rule for radicals, but going backwards, I can rewrite it then as the square root of 100 times the square root of 3. And then to simplify that, the square root of 100 is 10 and root 3, since the square root of 3 does not have any more perfect factors in it. So the square root of 300 simplifies to 10 root 3. All right, don't believe me? Need some more practice? Well, you're in luck. I got a couple more practice problems here if I can find them. Let's look at the square root of 75. Our job is to figure out, are there any factors of 75 that are perfect squares? And if we can choose, let's choose the one that's the highest perfect square. Well, 75, it feels like there's a 25 in there. Well, not times 5, times 3, because 25 is a perfect square. I can rewrite that then as the square root of 25 times the square root of 3. Square root of 25 equals 5, and I'm left with the square root of 3. And the square root of 3 again does not simplify because there's no perfect squares involved in that particular example. All right, let's get into cube root world. So I have the cube root of 54. So I got to think about what are my perfect cubes numbers. And we've talked about this before. The perfect cube numbers are 1, 8, 3 squared is 27, 64, 125, and those are the ones I want you to be most familiar with. So are there any factors of 54 that are one of these perfect cube numbers? And if so, let's rewrite it as such. 54, well, 27 is a factor. So 54 can also be written as 27 times 2. Break it apart into their own specific indexes or roots. So the cube root of 27 times the cube root of 2. The cube root of 27 was a 3. And the cube root of 2 cannot be reduced any further because there's no perfect cube roots that are a factor of 2. So my result then is 3 cube root of 2. And that is in its simplified form. The fifth root of 64. Now that one's going to be a little bit more difficult to work with. So with practice, one of the fifth root numbers that we are very much comfortable with knowing is 2 to the fifth. So I'm going to rewrite 64 as the fifth root of 32 times 2, because I know that the fifth root of 32 is a perfect fifth. Fifth root of 32, 2 times 2 times 2 times 2 times 2. And then I'm left with a fifth root of 2. And I can't simplify that any further because 2, there's no factors of 2 that are perfect fifth numbers. Last example, let's look at the square root of 500 xy squared. First of all, I want to break them down all into their perfect factors if there's any perfect squares. So I'm going to rewrite this. 500 I know is has a factor that's a perfect square. That would be 5 times 100. Times 100. 100 is a perfect square. Then I have the x, y, and the square. Let's write those up all into their individual roots. So I have the fifth root, or the square root of 5 times the square root of 100 times the square root of x times the square root of y squared. If there's multiple terms, I know this definition is just with a and b, but it could be with a, b, c, d, e. It could have lots of terms inside of it. And we can take each term and put it over its own specific root. Square root of 5 is reduced. There's no factors of 5. That is a perfect square. The 100, I can pull that one out. So I'm going to pull that one out first. So the square root of 100 is a 10. Square root of x, there's no perfect squares in that. But the square root of y squared, yeah. What is the square root of y squared? It's y, but we're also wanting to make sure that we are working with the non-negative numbers. So I'll make it an absolute value of y. And then the numbers that are left is times square root of 5 and the square root of y squared. And then lastly, to clean that on up, so there's only one index or one root, I'll make it as a 10 y square root of 5y squared. That is simplified. I know maybe it doesn't look like it's simplified to you. You'd rather have it like that, but we must simplify where we can. And simplification occurs if one of the factors involved underneath is a perfect square, perfect cube, perfect fourth, whatever the index may be. We must extract that out in order for it to be reduced.